is this one. Okay? It's called Where Did I Last See This? Okay, now let's take this question from the Senior Maths Challenge. We've decided that one of those is 2 less than 100. One of those is 2 more than 100. When did you last see something like that? Does it ring a bell? What bell does it ring? What general topic was it in? Say it loud.
Expanding.
It's in expanding brackets. The same bracket twice, once to the plus, once to the minus. Where does that come from? It comes from difference of 2 squares. So the answer is 10,000 minus 4, 9,996. Way faster than doing 98 times 102 slow. Okay, so that's a nice little simple of how just thinking where did I last see something can solve a problem very, very fast. But I'll give you an even better example. Now we're not going to solve this problem properly, but I'm going to just show you how it can get you a start on something that is super difficult. And this is from one of the hardest questions I've seen. It was, I think, question 24 in the senior paper about 5 years ago. And okay, it's this question here. Okay, right, so there's this point P and it's inside a square QRST. It's completely random, it could be anywhere. So let's do a diagram, that's another classic strategy. Could be there, could be there, could be there, could be there, could be there. But, in fact, it couldn't be anywhere, it has to be somewhere so that an angle is acute. So RPQ has to be acute. So it could be there, because that angle is acute. Now I'm just going to have a bit of a muck around here. I'm going to put in another example where it's acute. Let's try there. Is that acute? Just by a whisker it is. And here's the strategy. Where in your maths career did you last see something like that? What topic was it in? Say it loud, Vasu. Circle theorems. And that's the crucial thing. This question, which starts out about squares and probabilities, actually ends up using circle geometry. And there's no way you would think of that unless you were like some maths genius. But if you just have a bit of a muck around and think, where did I last see something like that? Even if it was some completely different topic, that might get you a start that solves the problem. Now, in fact, what's the boundary between being acute and not acute? 90 degrees. Well, you know what it takes for something to be 90 degrees. Isn't one of your circle theorems that if you build a triangle using a diameter, you always get a right angle? So in fact, you just have to work out the area of this semicircle, make it a fraction out of the square, and that's your answer. Okay? But that's not my point is finishing it. My point is starting it. How do you get a start on super difficult questions? Because remember my famous statistic? In the GCSE of 2012, if all the students who got 0 out of 4 or 0 out of 5 managed to just get 1 out of 4 or 1 out of 5, another 25 students would have crossed the grade boundary they were nearest to, whether that was a B becoming an A becoming an A star, or whatever.